Okay, so today we're going to talk about simplifying rational or radicals with exponents. So there's kind of a different way that we can write our radicals, and we can actually write the exponent as a fraction. So this will help us when we want to when we want to multiply or divide um, radicals that have different indexes. So we have our index, which is n, and we have our exponent, which is m. So we can write this as exponent and we would write it over our index. So we're always dividing by our index. All right, so our common examples are if we have an index of 2, if we have a square root, then that's the same thing as writing it as 1 over 2, because a has a 1 there. If we have a cube root, it's the same thing as writing it as 1 over 3. Same thing with the fourth root, and same thing with the nth root. We have an n and an n. And I'll come back to the exponent rules in just a minute. So what we're going to talk about is how we can rewrite a radical to have a rational exponent. So we have our exponent. So we're going to go ahead and write a as our base. We have an exponent of 3, and we're going to divide it by our index, which is 4. And we want to make sure to reduce that fraction if we can, but 3 over 4 is already in reduced form, so we would just leave it like that. So for number 2, our index would be 2. So we would have b cubed over 2, so over our index. We again can't simplify that at all, so we're going to leave it like that. All right, so for number 3, we have a 2 on the outside, so let's make sure to keep that 2 on the outside. And now we have 2 b's on the inside, so we're going to have b squared over 3, so over our index. And we cannot simplify that any further. All right, and the next one is just like our example up top. We have a 1 on this x inside, so this would just be x to the 1 over our index, which is 4. All right, so this next one is where it gets a little bit trickier. So we have a number inside and we have a 5th root. So we're going to go ahead and simplify that 32. So because it's to the 5th root, I'm going to break it down. So we can divide it by 2, and that would leave us with 16. We can divide it by 2 again, and that would leave us with 8. 2 again, and that would leave us with 4. And then 2 again, and that would give us 2 2's. So we're circling groups of 5 because of this index we have. So we have 1, 2, 3, 4, 5 2's. So we're going to have 1 2 on the outside because we have 5 2's. So we have one group of 5. All right, so then what we're going to do is we're going to divide our exponent. So we have, for x to the 10, we have x to the 10. I'm just going to write this above for now. We have x to the 10 over 5, which we can divide, and we're just going to be left with 2, because 10 divided by 5 is 2. And then we're going to have y to the 3 over 5, because that one is y cubed, and we're going to divide it by the index. That we can't simplify at all, so we're going to leave it like that. So make sure to check if you can simplify. If you can't, then that's your final answer. All right, so now this is where it gets a little bit different. So these are already in exponential form, but we need to write them where they only have one base. So when I'm talking about the base, I'm talking about what is being raised to the power. So in this case, it's x. So it's going to stay x. But what we're going to do when we're multiplying those bases is add the exponents. And remember, when we add fractions, we have to have a common denominator. So if I have 1 on top or sorry, they both have a 7 on the bottom. And so I'm just going to do 1 plus 4, which is 5, over 7. Can't simplify that. That would be our final answer. So we're going to do the same thing for the next one. We still have a base of x. Now we need to add the exponents. But this time they don't have a common denominator, so we need to get a common denominator first. So we're going to need to multiply this first fraction by 2. So we're going to have 2 over 6. Then we're going to have x to the 5 over 6. So all we did was multiply that first fraction by 2 on the top and the bottom so that it had a denominator of 6. Then we're going to add them together, and we have x. I'm going to move this down so we have more space. So we're going to end up with x to the 7 over 6. And that would be our final answer. All right, so the next one, we're going to do the exact same thing. We're going to add our exponents. Our base is 5, so it stays 5. I know you're going to want to multiply 5 times 5, but we don't do that. We're going to just leave it as 5, and we're going to write it to the 1/2 plus 1/2. So 1/2 plus 1/2 is going to be 1. So our answer would just be 5. All right, when our exponents are like this, we multiply them together. And if you're not sure, or if you don't remember your exponent rules, I have them all written up here at the top of your paper. So you can always refer back to those if you need to. So we're going to go ahead and just multiply straight across. So we have an x. We're going to multiply the tops. So 1 times 2, and then the bottoms. So 4 times 3 is 12. So we finally have one where we can simplify that fraction. We can divide both 2 and 12 by 2, and we'd end up with 1 over 6. All right, and then the last one for this section, we are now dividing. So when we divide, we need to subtract our exponents. So we're going to treat our numbers like we always do. So I have 4 over 2. 4 divided by 2 is 2. And then I'm going to subtract the exponents. They already have a common denominator, so we just have 7 over 8 minus 1 over 8, which is going to be 6 over 8. And again, that can simplify. So we still have that 2, we still have x, and it's going to be to the 3/4. And that would be our answer. All right, so for the next section, now we're going to switch back and make this a radical. So remember, anything on the bottom is going to be our index. So I'm going to go ahead and circle all of my indexes for the next couple problems. So on some of these, we're going to simplify first and then write it as a radical form. So if we think about this first one, we have an index of 2. So that means we have just a square root and x to the first power. So it's just going to be 1x on the inside. For the next one, we have an index of 3. So we're going to have a cube root, and then we have a 2 up top. So we're going to have x squared on the inside. So for this next one, we have 16 to the 1/2. So that's the same thing as writing the square root of 16. And we know the square root of 16 is just 4. All right, same deal with this next one. So we have 25 over 36 to the 1/2. So this is the same thing as 25 over 36 under a square root. And we can actually use what we learned last time to break this up to be 25 over square root 36, which would simplify to 5 over 6, because the square root of 25 is 5 and the square root of 36 is 6. All right, and for the next one, number 15, so now we have a negative exponent. So whenever we have a negative exponent, we're actually going to flip our base over, and we're going to make it positive 1/3. And now we can write this as 1 over the cube root of 27. And we know the cube root of 27 is 3, so we can make it 1/3. All right, and then for number 16, we have exponents again. Let's go ahead and add them before we do anything else. So we're going to have, oh, actually, we have a different base here, so we cannot do anything with them. We're just going to go ahead and write them as radicals. So because we have an x and a y, we can't do anything with the exponents. So we're going to go ahead and they both have an index of 5, so we're going to have a fifth root. We're going to have x to the third, because of that 3 on top, times y to the 32, because of that 32. So we can simplify that a little bit. We have 32 y's on the inside. We can think about this 32 as, I'm just going to write this up here, as y to the 30 times y squared. So we can divide 30 by 5, and we're going to get 6. So we'll have y to the 6th on the outside. And then we're still going to have 3 x's on the inside and 2 y's. All right, and last one, they don't have the same base again, so we're just going to do them each separately. So on the top, we're going to have the square root of 16 because it's 1/2. And we're going to do the square root of 9, and that would just end up equaling 4 over 3. And that would be your final answer. All right, make sure to check with me if you have any questions, and then try to do the next couple on your own and check your answers on Schoology.